my voice is clear?
Yes, ma'am.
Okay, so this is your task 5 class of data analysis, right? Yes, this is your task 5 of data analysis, right?
Yes, ma'am.
Okay, okay. So for this task, I'll give you the description that in this we have to do a project on a heart disease. Okay, so okay, so we have to analyze a heart disease data set. Okay, and we have to apply all the skills that we have learned so far in this internship. Okay, this you can also include in your resume. Okay, so now I'll show you the code of the heart disease analysis part. Okay, so basically, first of all, in this you have to import all the necessary libraries that we need. Okay, so first is okay. So in this you have to import all the necessary libraries that we need. Okay, so first is import numpy as NP. NumPy library you all know is used for handling the numeric data type. Okay, just wait for a minute. Okay, so yes. So first of all, you have to load import all the necessary libraries that we need for this analysis. So first is import numpy as NP. NumPy library you know is used for handling numeric data type. Second comes the pandas library, which you know, which is the basic library that we have to import always. Then comes the matplotlib.pyplot library. This also you know, this is for the plotting purpose. Okay, this library is useful for the visualization. Okay, so for plotting the different kinds of charts and plot, we have to import this library. Then comes C1 library. So C1 library is the advanced library for visualization. Okay, in this there are advanced level of plots and charts. Then comes percent matplotlib inline. Okay, so this library basically allows you to display plots and visualizations directly within the notebook interface. Okay, so rather than in a separate window, by using this library you can easily generate and view graphs, charts, and like other visualizations. Okay, in line. Okay, in same line with your code. Okay, making it convenient for the data analysis. So for this library you have to import. Okay, then comes your second task, which is importing your data set. Okay, so how to import a data set? So you know how to import a data set. First of all, you have to set any variable name, then equals to pd.read underscore csv. This function you have to use. Okay, and inside the parentheses and in between the inverted commas, you have to copy the location file of your data set. Okay, then we have to use some of the functions for analyzing our variables. Okay, so this is for checking first 5 rows. Okay, so you know head function by default will give you top 5 rows of your data set. Okay, so by using the head function, here is your top 5 rows of your data set, and these are the column names, which is age, sex, cp, stress, bps. This is cholesterol, this is chest pain, this is sex, this is age, this is target, this is for maximum heart rate, and so on. Okay, and comes the df.tail. This tail function gives you the bottom 5 rows of your data set. Okay, so these are the bottom 5 rows of your data set. Now we'll take a look at the column names. So here are all the column names. Okay, by using the columns dot values function, you can take a look at the column names separately. Okay, now we'll check for the null values that is there any null values in our data set or not. Okay, and by using the is any dot sum function, here it will show you all null values present in each column. So there are no null values present in any column. Okay, and if there were the null values, then you have to handle. Okay, but there is no null values in this data set, so we don't have to handle our null values. Okay, then comes the concise summary of your data set. So for finding the concise summary of your data set, you have to use info function, df.info. It tells you how many non-null counts are there, okay, and the data type of your columns, each column. So all the data type is integer except the old paid column, which is in the float data type. Okay, so info function will basically give you the concise summary of your data set. Now comes the plotting histogram of all numeric values. All numeric value means all columns name. Okay, so this is your histogram. So how to plot a histogram? You know, you have to use hist function for this. Okay, you have to use hist function for it. Then inside the parenthesis, here is first is the bins, and bins is here 50. So basically what is bin first? Okay, so bins refers to the interval or ranges. So these are the bins, interval or ranges, into which data is divided for analysis or visualization. Okay, and if we do here 100, now I think it will be easy to you all to understand what is bins basically. Bins are interval or ranges. Okay, so now see the ranges is increased. Okay, so these are basically bins. Now comes the grid. So grid is basically the background line. Okay, grid is basically refers to the set of evenly spaced lines in the background, or you can say dot, or you can say dot that form a network, okay, on a graph or plot. So if we do here true, then you'll see what is grid here. See, this is your grid. Okay, means the set of evenly spaced lines that form a network of reference points on a graph or plot. Okay, so if you want grid, then you can use here grid equal to, otherwise you can set here false. Okay, so I'm changing again to false, and I'm also changing the bin ranges. Okay, and okay, then comes the figure size. This is 20 comma 15, which is length and breadth of our each figure is 20 comma 15. Okay, so this is how you can set, and this is how you can make plot a histogram of all numeric values of your data set. Okay, so these are the histograms of all columns, which is first is age, then comes the sex, then CP, TRES, VPs, cholesterol, FBPS, and so on. Okay, so that we can get a clear vision about our columns. Okay, now comes to generate a descriptive statistics. So you know, by using the describe function, you can generate a descriptive statistics of your particular data set. So these are the descriptive statistics of your data set. Okay, count, mean, std, and it is of the all the columns. Okay, so till here we have analyzed our all data set. Okay, and we check the null values. There are no null values. Uh, there are no null values. Okay, and we have use the info function and describe function for concise and descriptive statistics of your data set for showing, and this is your histogram for analyzing your all columns. Okay, now we'll go towards the questions part. Okay, so here I've taken 4 questions. Okay, in this you have to take minimum 7 questions by your own. Okay, minimum 7, because means these are 4, and you have to add 3 more by yourself. Okay, and maximum till 10 you can go. It depends on you and your creativity and your thinking part. Okay, so these are the 4 questions. You have to add minimum 7, or maximum till 10 you can go. Okay, so you have to make 7 questions. Okay, these are 4, and you have to add 3 more. Then you have to find the solution of each question by using appropriate function. Then you have to solve that particular answer, okay, in the visualization form too. So this is the first answer by using the appropriate function. Now we will visualize this answer in the plotting, in a plot or a chart form. Okay, so yes, this is how you have to do this. So now these are the some of the questions. Okay, now we'll solve them one by one. Now comes the, let's find the answer of first question. Okay, first question is how many people have heart disease and how many people doesn't have heart disease. Okay, so for this we are using our target column. Okay, in target column, first of all I'll see, first of all see the target column. Here 0 represents the person not having any heart disease, and here 1 represents the person having heart disease. Okay, so by using the target column we have to analyze that how many people have heart disease and how many people doesn't have heart disease. So for getting the values we are using the target column df dot target dot value underscore count. Okay, so for getting the value we have to use value underscore counts function. So these are the values. It says 526 people having heart disease. Okay, people have heart disease, and 499 people doesn't have any heart disease. Okay, so now we'll visualize the same answer in the bar chart. Okay, or you can say bar plot. So here we are using this variable. Okay, we have dot target this answer dot plot. So kind is bar, color we have fixed, which is orchid. First is orchid, second is salmon. Okay, and you know how to set the title, x label, y label. Okay, so these are the title, which is heart disease values. This is the label. X label is 1 is equal to heart disease, 0 is equal to no heart disease. Then comes the y label. Y label is amount. Okay, so this is your bar plot showing how many people having heart disease. Okay, and how many people doesn't have having any heart disease. Okay, so yes, so now we'll plot a pie chart for the same answer. Here dot plot function we have to use, and now kind is your pie. Okay, and this is your figure size. I have told you figure size is your length and breadth, okay, of your figure. So here you can also increase your figure. Okay, so here, so it's basically depend on you what kind of size of chart and plot you want. Yeah, in your analysis report. Okay, so this is your pie chart and this is your legend, plt.legend. By using legend function you can set the legend. So this is your first legend, which is disease, and second is no disease. So here blue color represents the people having heart disease and orange color represents people having no heart disease. Okay, now we'll move towards another. Okay, now we'll check another thing, which is first of all look this. Okay, here in sex column 0 represents female and 1 represent male. Okay, in sex column part, and target column, you know, 0 represent no heart disease, 1 represent disease. So now let's check how many male and female are in the data set. So we have to check a male female ratio. So for this we are using our sex column. Okay, so by using the sex column dot value underscore count, now we'll calculate the value of our male female. Okay, by using the sex column. So here is your answer. 1 represents male part, 0 represents female part. So there are 713 people are male and 312 people are female. Okay, so and now we'll plot a pie chart for the same answer. Kind is 5, figure size is 86, title is male female ratio, legend is male female. So here blue color represents the male ratio and orange color represents the female ratio. So from this it is very clear that male is double the number of female in our data set. Okay, yes. So now let's find the answer of our second question, which is people of which sex has most heart disease. Okay, so for this we are using the cross tab. So it's basically short form of the cross tabulation. Okay, so basically by using the cross tab function it creates a cross tabulation table that display the frequency or count of occurrences for each combination. Okay, for each combination of categories from the variable. So like this helps in understanding the distribution and relationship between variables. Okay, so we are using the cross tabulation for showing the distribution, for showing the relation between the target and sex column. Okay, so here it is showing the cross tabulation result. So here set 0 represents female, 1 represents the male part. Okay, uh, yes. So here 0 represents female and 1 represents the male part, and here 0 represents no heart disease, 1 represents having heart disease. So here 86 number of female having no heart disease and 226 female having heart disease, and this is for male part. Okay, now we'll plot the count plot for the same answer. Okay, so what is count plot? It is a advanced plot, okay, which is in C1 library, you all know. So yes, count plot we have already did in a previous task. Okay, so this is your count plot. So sns.countplot, this function you have to use, and your access target data is df, hue is set. So hue parameter basically allows you to introduce an additional variable, categorical variable to your plot. Means it helps in visualizing your variable, okay, by setting the different colors for the different answers. So basically we have two sets currently in our data set, which is male and female. So hue parameter will set different color for the different values, which is male and female, so that we can easily differentiate between the two, okay, between the two sets. So hue is sex, your title, you know how to plot, and this is your x level. So this is your heart disease frequency for sex. Okay, so from this plot, from this count plot, it is we have concluded that number of male is more than double in our data set than female, obviously. Okay, then comes the more than 45% male has heart disease. Okay, more than 45% male has heart disease, and 75% female has heart disease. Okay, now we'll move towards our question 3, which is people of which sex has which type of chest pain most. Okay, so for counting the values for different chest pain, we are going to use our CP column, which is chest pain column. Okay, and here is our result: 497 people having zero kind of chest pain, 284 people having second kind of chest pain, 167 people having one kind of chest pain, and 77 people having third kind of chest pain. So now we'll plot a bar chart for the same answer. Here kind is bar, color we have fixed, which is first is salmon, this is salmon, then is light sky blue, then is spring green, this is your spring green, then is khaki. Okay, so this is your khaki, and title is chest pain type versus count. So it will show you that how many people having which kind of chest pain most. So most is zero kind of chest pain. Okay, now we'll plot a cross tabulation between a sex and a chest pain, that which sex having more kind of chest pain. So this is for the female part, and one is for represents male part. Okay, so this is your cross tabulation between sex and CP column. Now we'll plot a bar chart for the same answer. Okay, here we have fixed the color is coral, then light sky blue, then plum, this is your plum color, then comes the khaki. You can add your colors, okay, for making it more visually appealing. Okay, so depends on you and your creativity. So this is your title, and X label is your 0 represents female, 1 represents male part. Okay, so this is your type of chest pain for sex. So from this we have concluded that most of male has type 0 chest pain most. Okay, 0 kind of chest pain, and least of male has type 4 pain. And in case of female, type 0 and type 2 percentage is almost same kind of. Okay, now we'll move towards our last question, which is people with which chest pain are most prone to have disease. Okay, so for this here, first we are plotting the cross tabulation between chest pain and target column. Okay, chest pain and target column, this is our result, and we'll plot our count plot for the same answer. Here x is our chest pain column, data is df, hue is target, to know what hue parameters do. Okay, it will set different colors for the different targets 0 and 1. Okay, so from this count plot we have concluded that most of people who has type 0 chest pain has less chance of heart disease. Okay, and we see the opposite for the other types. Okay, like see, most of people who has type 0 pain has less chance of heart disease, and but the opposite of other types. Means less people having this kind of chest pain were having high chance of having heart disease. Okay, so this is for opposite for other types. Now let's take a look at our age column. Okay, so by creating a distribution plot with normal distribution curve. So now comes the this plot. So basically what is this plot? It is also an advanced plot which is in C1 library. Okay, and it is a short form for the distribution plot. Okay, this plot is a short form of distribution plot. So it is basically display the distribution of a single numerical variable. Okay, basically it combines a histogram with a kernel density estimate. Okay, with a kernel density estimate plot, providing a like comprehensive view of your data distribution. So this curve represents the kernel density estimate. This is KDE. Okay, so this is your displot. For this you have to use displot function, sns.displot function. Here x is age. Okay, here x is only one column which is age, and you have to use only one column in this because it's just like a histogram. Then data is df, bins is 30, you know what is bins, interval ranges, and kd is true, means this kernel density estimate curve is true here. Okay, so if you do here false, now you see the result. See, now that line is gone. Okay, so if you want that, if you don't want that curve, then you can use here false. Okay, now this is your case. Now from this plot, it is clear that 58 to 59-year-old people are most in our data set. Okay, now comes the let's plot another distribution plot for maximum heart rate. Okay, so for maximum heart rate, we're going to use Thalage column. Okay, it shows the maximum heart rate. Data is here, bins is 30, KD is 2, color is chocolate here. We have set a color in this which is chocolate. So this is your KD curve. Okay, and from this plot we get a clear overview about maximum heart rate represented by Thalage. Okay, so yes, we have analyzed our heart disease data set. Okay, we have done all the questions that we created. Okay, so basically, yes, this was all your task 5, which is you have to analyze your heart disease data set. Okay, that we're going to provide you that data set. So first of all, you have to import all the necessary libraries. Then you have to load a CSV file into your Jupyter notebook. Then you have to use some of the functions for analyzing your variables. Then you have to check for the null values. If there are null values, then you have to handle it. But there are no null values in this data set. Okay, then you have to use info function, and you have to show by using, you have to plot histogram of all numeric values of your data set. Then you have to use describe function for showing descriptive statistics. Then you have to make minimum 7 questions. These are the 4 questions. You have to add 3 more in this, and maximum till 10 you can go. Okay, and you have to solve each question by using the appropriate functions. Okay, then you have to visualize the same answer. Okay, so yes, it depends on you what kind of visualization you want, and choose wisely. It should be not be crowded. Okay, and whether it is bar chart or line chart, disk plot, count plot, it depends on you. It depends on your creativity, or pie chart. Okay, so yes, you have to solve each question by using the appropriate function, and then you have to do a visualization. So I hope this was all your task 5.